Dear students, today in this video we are studying recursive formula for geometric sequence. Geometric sequence is a progression of numbers in a way that every successive number is obtained by multiplying its preceding number by a constant number r. Let we are having a geometric sequence. This is our first term, this is second term, this one is third term, and this second term 8 is obtained from 16, which is first term, by multiplying it with 1 by 2. So 16 is multiplied with 1 by 2 and we are getting 8, and this 4 is obtained by multiplying this 8 with 1 by 2. So what will be the next term? 4, 5. The fourth term will be obtained from the third term by multiplying it with 1 by 2. So if 4 is multiplied with 1 by 2, we are getting 2, which is the fourth term. And this 2 is multiplied with 1 by 2 and we are getting the fifth term, which is 1. In the similar way, we will proceed and we will obtain the whole sequence. So this is written, 8 is obtained by multiplying 16 with 1 by 2, and 4 is obtained by multiplying 8 with 1 by 2, and 2 is obtained by multiplying 4 with 1 by 2, and 1 is obtained by multiplying 2 with 1 by 2. So what is this? 8 is the second term. Second term is obtained from the first term by multiplying it with 1 by 2. Third term 4 is obtained by multiplying the second term 8 with 1 by 2, and the fourth term 2 is obtained by multiplying the third term with 1 by 2. So if we proceed in this manner, this is the general term. So general term, what is the number before this general term? This is an. So the preceding term is an minus 1. So this an is obtained by multiplying this preceding term an minus 1 with 1 by 2. So this means an is obtained by multiplying an minus 1 with 1 by 2, and this is the recursive formula for this geometric sequence, where 1 by 2 is r. So an is equal to an minus 1 multiplied by r, because this r will be changing and these numbers will also be changing, but this is the general formula for geometric sequence, and this is recursion formula, because the next term is obtained from the preceding term by multiplying it with r. Now how this r will be obtained? If we are given some geometric progression, we are taking this progression, this sequence in consideration. So if we divide the second term by first term, that is 8 divided by 16, we are getting 1 by 2. And if we divide the third term by second term, we are getting 1 by 2. And if we divide the fourth the fourth term by third term, again we will be getting 1 by 2. So these are same. After division we are getting the same number, and this is known as R, and we say this R is common ratio. Generally the sequence is written as A1, A2, A3, A4, A5, and so on, an minus 1, an, and so on. This is the general term, and what is before general term? This one. So an and its preceding term is an minus 1. Now a2 is obtained by a1 by multiplying this a1 with r. A3 is obtained by multiplying a2 with r. And a4 is obtained by multiplying a3 with r. A5 is obtained by multiplying a4 with r. And an is obtained by multiplying an minus 1 with r. And this is the recursion formula for every geometric sequence. First we will find r, and we will put the value of r over here, and that r will end the first term or any term of the sequence if it is in knowledge and we are given that number, some number of the sequence, and we are given the common ratio, then we can generate the whole sequence. We can also view this geometric sequence with another aspect, a2. If we divide a2 with a1, so what will be the value? So take this on the left side, we are getting a2 divided by a1 is equal to r, and similarly over here a3 divided by a2 is equal to r. So r can be obtained each time by dividing the next term with the previous term, and in these two, next term is divided by the previous term, and we are getting the same number r each time, and this r is known as common ratio. So this can also be written in this way, that an divided by an minus 1 is equal to r, and this is also the recursion formula for geometric sequence. Thank you. We are taking an example. Find geometric sequence if the fifth term is 3 and the common ratio is 1 by 4. As the recursion formula is an is equal to an minus 1 multiply r, and r is given. R is 1 by 4. And now we will take n is equal to 5. So A5 is equal to A5 minus 1 multiply R. So A5 is equal to A4 multiply 1 multiply R. A5 is given 3, so A4 multiply 1 by 4 because R is 1 by 4. This means A4 is equal to 3 multiply 4, which is equal to 12. Now again I am taking an and n is equal to, now I am taking, because we have found a4, so I will take now n is equal to 4. A4 is equal to a3 multiply r. I have put now n is equal to 4. A4 is 12. So 12 is equal to a3 multiply 1 by 4. Multiplying both sides with 4, I am getting a3 is equal to 12 multiply 4, which is equal to 48. Now again, now we have found a3, so now I will put n is equal to 3 in this recursion formula. So a3 is equal to a2 multiply r. A3 is given 48 now, so a2 multiply r. So by this a2 is equal to 48 multiply 4 to 192. 4 8 the 32, 3 4 4 the 16 and 3 19. Now I have found second term, so now I will take n is equal to 2 in this formula. So a2 is equal to a1 multiply r. Putting the values, a2 is 192 and a1 multiply r 1 by 4. So this means a1 is equal to 192 multiply 4. 4 2s are 8 and 4 9s are 36. 3 4 1 is 4 7. 768. Now we are in a position of a geometric sequence now. What is the first term? Now 768. This is our first term. What is the second term? 192. And what is the third term? 48. And what is the fourth term? 12. And so on. So this is the geometric sequence. This is our first term, this is our second term, this is our third term, this is our fourth term, and so on. We are taking an example that find the geometric sequence if the fourth term is 54 and the first term is 2. Now I am taking the recursion formula, an is equal to an minus 1 multiply r. We are not knowing r, we are knowing the fourth term and the first term. Now put n is equal to 4 in this recursion formula. We will be having a4 is equal to a3 multiply r. Over here coming the number 3, because 4 minus 1, n is 4, 4 minus 1 is 3. Now put n is equal to 3 In this recursion formula, we are getting A3 is equal to A2 multiply R. And now put n is equal to 2. So A2 is equal to A1 multiply R. And now we are having this value and we are having this one. Okay, so put over here first the value of A4. So 54 is equal to A3 multiply R. Clear? Now remaining is, what is the value of A3? A3 is A2 multiply R. So 54 is equal to the value of A3 is A2 multiply R. And this one is, so this is the value I have put A2 multiply R, which is the value of A3 from this equation. So this will proceed as A2 multiply R square. So 54 is equal to A2 multiply R square. Now what is the value of this A2? A2 is equal to A1 multiply R. A1 multiply R. This is the value of A2. So 54 is equal to A1 multiply R cube. And now what is the value of A1? A1 is 2. So 54 is equal to 2 multiply R cube. This means R3 is equal to 54 divided by 2, which is equal to 27. So R cube is 27 and R is 27 cube root, and this is equal to 3. This means R is 3. Now first term is 2 and the fourth term is 54 and R is 3. So now we are taking this first term. To generate the second term, we will multiply first term with R. So what is first term? 2, and it will be multiplied with R 3, so 6. Now third term is obtained by second term by multiplying second term with R, and second term is 6, so 6 multiply R 18. And now fourth term is obtained by third term multiply R, so third term is 18 and multiply R 54. And now fifth term can be obtained by multiplying fourth term with R. So what is fourth term? 54 multiply R, 3 4s are 12 and 3 5s are 15, 16. So the geometric sequence is obtained is, what is the first term? 2. What is second term? 6. Third term 18. Fourth term is 54 and fifth term is 162 and so on.